Hey you guys, welcome back to another video, and today we're going to go over the lines inside a triangle. Let's begin. Before we get started, I'd like to go over some key terms. A median, a line that connects the vertex of a triangle to its opposite side's midpoint. So, this is median. This is the vertex in which it connects, and as you can see, side BC is the opposite side and it connects the midpoint. Next up, we have our altitude, a line segment that connects a vertex and it is perpendicular to the opposite side of that vertex. So we have an altitude coming from vertex B and its opposite side is AC, and as we can see, it is perpendicular to it. On to our last set of terms, an angle bisector, a segment that divides an angle triangle into two halves. As you can see here, angle AOB is 60, and onto the next image, AOB is cut into two halves by the angle bisector, to 30 and 30. Finally, we have a perpendicular bisector, a segment that is perpendicular to the line it cuts into two equal halves. So as you can see, QS is our angle bisector, and it cuts this segment PR to two equal halves and also is perpendicular to it, creating a 90-degree angle. Let's move on to the types of lines in a triangle. An orthocenter is a point in the triangle where the altitudes meet. So you can see this is the point where this is the altitude, and these are our different altitudes. Next up, we have a centroid. It's a point in a triangle where the medians meet, the medians. This is our centroid and this is our different medians. Now on to our last two. An incenter is a point where all the angle bisectors of a triangle meet. As you can see, this is our angle bisector, another angle bisector, another angle bisector that meet at one point here, which is the incenter. Next, we have a circumcenter. It's a point where perpendicular bisectors of a triangle meet. As you can see, they create 90-degree angles with these segments. And they also, wrong one, but they also split these segments into two equal halves. And they meet at point K, which is our circumcenter. One final thing that I would like to say is that a centroid has a special property. It divides each median into a 2-to-1 ratio. Let's take, for example, the median AB. Now the centroid here, you see that segment BC is 3 and segment AC is 6, meaning that AB is 9 and BC is 3, AC is 6. And notice how it was turned into a 2-to-1 ratio. Now, to identify the longest side, it'll always be the part that is closest to the vertex that it comes out of, which is vertex A. Now, to end this video off, let's go over two practice questions. Alright, number 15. Diagram below, triangle ACE, medians AD and EB and CF intersect at point G. The length of FG is 12 centimeters. What is the length in centimeters of GC? Now, you can pause the video and try and solve the question. Alright, welcome back. Now, let's analyze this question. It says that the medians AD and EB and CF are in the triangle, meaning that we're dealing with a centroid. A centroid is where all the medians meet and intersect at one point. And we're given that point FG is 12. Now, remember what I said earlier, how the centroid had a special property? That it cuts a median into 2-to-1 ratio? Now, let's apply our skills now. Now, I said that the longest segment will be the half that is closest to the segment, which is C. So let's make a ratio. So we have 12 here, and let's have x as GC. Now, we want to find something that has a 2-to-1 ratio. So let's find what's double the 12. 12 times 2, and we get 24. Answer is 24. Now let's go on to number 13. In the diagram below, triangle ABC, segment AE is congruent to BE. Segment AF is congruent to CF. Segment CD is congruent to BD. Point P must be the... Now pause the video, try and solve this question. Alright, welcome back. Alright, so we see that AE is congruent to BE. Next we have CD is congruent to BD. Finally we have AF is congruent to CF. Now, what you guys will notice here is that this is being cut in half by AD, meaning that AD is a median. Likewise, for segment AB, it's being cut in half by CE. AC is being cut in half by BF, meaning that they are all medians, making this a centroid.